Good morning, friends. This is Miss Hinton making this video for you from far, far away. Unfortunately, my soap expert was not able to get in to talk to you today due to illness, so excuse me. I'm going to do my best to work from her notes. You can find this slideshow ready for you to fill in the blanks in your Google Classroom, and we'll have a quick quiz over this on Thursday. Okay, let's talk about saponification. Soap, in and of itself, is a chemical created from the reaction of a fatty acid and a base. And that set of ingredients should sound familiar to you. What kind of reaction is that? You guessed it, neutralization. So that's why you have to be a little careful. We're using an acid, which is not too scary in this case because it's made from animal fat, and a base. You do have to use cold process saponification. There's cold and there's hot processes, but we're going to use cold process, which means no crock pots. And you have to make it in my room anyway. Okay, so in our recipe we use something called lye. It is caustic soda or metal hydroxide or base. You'll see those names used interchangeably. It is dangerous to get on your skin. It's also used in drain cleaner. So that's why it's important to be really careful. I'm not going to talk to you about the history. If you want to Google that, knock yourself out. Okay, so we have fats in two categories, probably. You've heard of them before. Saturated fats, they have all single bonds. So everything that holds every atom together is bonded singly. These are what we know as the quote unquote bad fats. That's because they have all the ingredients there that they could possibly have. So examples of these would be lard, bacon grease, butter, and so they're usually solid at room temperature. That's how you can, one reason you can kind of tell the difference. Does it take very much for them to melt? No, they melt quickly. Fats do that. The other fat is unsaturated fat, and these have at least one double bond, and they can have from one double bond all the way up to all double bonds. And the more double bonds they have, the healthier they tend to be. So as you can see from the picture, what's the commonality between all unsaturated fats? That's right, they come from plants. So you can choose in your soap making recipe either kind. I have unlimited lard for you. And then there I have other types of fats left over from last year. And so before you buy anything, just let me know, and you can send me a text today on Remind or an email. Try to check that. Remind is easier, and I'll let you know if I have any of those things. If you desire to do a lab tomorrow, you certainly can. Just put your requisition form on my desk today so that I can come before school tomorrow and get that ready for you. When you are doing the saponification reaction, this is your jumping off point. So engineers and scientists, this is your basic reaction. So the OH group is for hydroxide, so you can use sodium hydroxide or potassium hydroxide. So that's what would go right there. This is what's going to make your fat, and this Y is just a stand-in for whatever your base acid chemical is. So if you're using coconut oil or avocado oil, whatever. And then on the other side, you're going to have your salt, which is what's left over, and this chemical is called glycerol. And you can see that the ingredients for water are a part of that. So just like lye has several names, fat has also several names, and so you'll see any of those. You won't find tallow anywhere, I don't think. It's really, really old-fashioned. They used to make candles out of it, and it would burn real black and gross. Anyway, um, glycerol and glycerin are the same. So we just need to know, what does saponification mean? It's the process of making soap. And so here is how soap works. I want you to think about your face as a good example, or plates in the dishwasher, or your, sweaty track uniform, whatever. So when a bunch of soap molecules get together around some dirt, that has a name. It's called a mycel. Mycel. So that's really important. That's going to be on the quiz 100%. So think about it this way. Here is on your face, you have some oil. Okay, and we want to get that oil off of there. And if you come in with some water, just plain water, even if it's hot water, some of that, yes, is going to come off. But if I tell you to go wash your face, I need to use soap. That's called washing. And here's why. Oil and water don't mix. We know that. So we need something to bridge the gap between oil and water so that we can wash away the dirt. Oil is the dirt in this scenario. So soap has two sides, a hydrophobic side that doesn't like water, that's this blue part, and that will hook onto the oil drop. Okay, then it has this water-loving side that will hook onto the water. So soap can hook onto both water and dirt, and then the water takes the whole thing away. That's why soap works. I hope your mind is blown. I love this. Okay. All right. So soap, in order to work well, has to have two characteristics. Number one, it has to be a surfactant. Okay. So surfactant, well, I didn't mean to do that. A surfactant improves water's ability to sink in. Okay. I don't know if you've ever had a microfiber cloth or something and you pour water on it and it just kind of makes a little bubble on top and it won't sink in. Okay, so soap is a surfactant, improves water's ability to be absorbed. Okay, the other one is an emulsifier. It helps. You should know what immiscible means, but just in case you don't, immiscible liquids are things that don't want to mix together. So an emulsifier helps two liquids that don't want to go together stay together. Okay, so this means that oil, which attracts dirt, doesn't naturally mix with water, and it helps to get the dirt off. So soap has to be a surfactant and an emulsifier. And you have to remember those things. When you're turning in soap, your soap has to be able to clean. And without being a surfactant and an emulsifier, your soap is not going to be able to clean a wide variety of things. All right, when you're making soap, there's 5 things you can change. Okay, you can change the type of fatty acid. So that's lard. You can use bacon grease, I guess, if you can get enough. You can change your hydroxide ion. I have sodium hydroxide and potassium hydroxide. Those are your 2 choices. You can change the color. You can change the scent. And you can change the texture. Okay, is it going to have an exfoliant in it? Whatnot. Okay? So when you're ready to add something that might change the texture or smell or color, you can add that when your soap looks like that picture. And if you made soap on Friday, this probably will hopefully look familiar. And the longer you stir it, the easier it's going to get to this point, which is called trace. So we add additives when soap is called et trace. Okay, so there's a little picture. So here, this is one site that I found that can be helpful. Let's see if I can bigify. Can I bigify this? I don't know. Nope. Okay, so I'm just going to go down and show you how this works. So if you're doing, you want to make black soap, which, okay, you can use activated charcoal, which is super, super cheap. You can get that anywhere. I might even have some of that. If you want to make brown soap, okay, here's some choices. If you want to make green, I've had people get alfalfa at the store and dandelion leaves, dandelions are crazy. Come to my yard and pick the ones out of my yard. That'd be great. So there's lots of choices for color additives on this website, and this is linked in your slideshow. One little thing that I think is important to know, and people have tried this before, melted crayons are not a good choice. So people have tried that before. It doesn't work well, and also it's not super. It's a petroleum product, and we kind of want to stay away from those if we can. All right, so that is most of what I want to say to you right now. Just keep in mind when you make your trial soaps, you probably want to make a very small batch first, and you can make as many small batches as your little heart desires. Don't forget things that are due today, and I will accept those at the beginning of the hour tomorrow. If you have questions, again, remind is the fastest way. I hope you do amazing today. See you tomorrow. Bye.